Hello friends, in this video I'm going to solve the mathematical physics question paper 2021, but it was held in 2022 January and February. So BSc first sem, this is for BSc first sem physics honors students. This paper is set by Dibrugarh University, C1 paper, mathematical physics, right? So let's solve. So before we start, please subscribe the channel if you are new to my channel and hit the bell icon so that you get notified when new video will be uploaded. And I have posted a poll in community post, so go and check there. I have asked if you want any course that you want me to create on physics. I have given options there: thermal physics, quantum physics, and other options also there. So if you want me to create new contents for you, just vote it. Okay, so now let's start. So here is the first question. Choose the correct answer. The partial derivative of this is, which one is correct? So if you if you differentiate this partially with respect to x, twice x y square. If you differentiate partially this term with respect to x, then you're gonna get 2y e to the power twice x. And if you differentiate this partially, and the derivative of x will be 1. So this one. So when you divide something partially with respect to x, then other variables should be considered as constant. Y should be considered as constant. Now from here we can take 2 common. 2x plus 2x, that should be y only, right? So which option is correct here? So I think option 2, that's a correct option. So now let's move on to the next question. So degree and order of the differential equation. Here you see, so the highest degree term is this one. This is second degree, and power on this term is 1. So that's why this is second degree, degree 2 and order 1. So here is the option 2. 2 is the correct option here. And to be irrational vector, this del cross s must be 0. So here also option 2 is correct. Okay, so in this also option 2 is correct. So here also option 2 correct, right? Then by Gauss theorem, so here option 1 is correct. So if you know the Gauss divergence theorem. So now you see, let's move on to question number 2. So that limit x tends to 0 sine 1 by x does not exist. So let me show this one. So it's very simple. So here you see, limit x tends to 0 sine 1 by x, right? First let us find the left hand limit. Left hand limit. Let us find that one. So how to find the left hand limit? So limit, here we're gonna write x tends to 0 negative. That means it represents left hand limit. That means values on the left side of 0, right? So x tends to 0 negative means that it is left hand limit, right? So that's gonna be sine minus 1 by h. If you put first let me write it is given as it is, sine 1 by x. So in the next step what you can do, so to find the left hand limit, what we need to do, limit. So here we have to take h tends to 0, function of the a minus h, that means 0 minus 1 by function of 0 minus h should be taken. That here function is sine 1 by x. So here we need to take sine 1 by 0 minus h, right? So then what you will get, limit here h tends to 0, then sine 1 by 0 minus h. That's what we will get, right? That's how we used to find a left hand limit, right? So now you see, actually this is taken as x minus h tends to 0, right? So we have taken like that way, equal to 0, equal to 0. So then if x tends to 0, then h also tends to 0, right? So we have assumed that way to find the left hand limit. So hope you got it now. So we have discussed those things in earlier paper also, how to find the left hand limit, right hand limit. So here we're gonna get minus limit h tends to 0 sine 1 by h, because 1 by 0 minus h is gonna give you 1 by minus h, and this minus h is written outside. Okay, so hope you have understood this. So now here you see, if you see this one, so if you put 0 here, then if you put 0 here, that's gonna be sine of infinity, and that's gonna be minus infinity. And similarly, if you find the right hand limit, then what you will get, limit x tends to 0. Here on plus means right hand limit, so sine 1 by x. So if you replace the x by here, you see, if you put if you use this, x is equal to 0 plus h, right? X is replaced by 0 plus h. Then when x tends to 0, then h must be tending towards 0, right? So now limit, here you can write h tends to 0, and you have to put here 1 by 0 plus h, and that's gonna be limit sine 1 by h, and where h tends to 0, right? And if you put 0 here, then it will be sine 1 by 0 means infinity, and sine infinity, this is infinity here. So here you can see we have got a positive infinity, and here we have got negative infinity. So since right hand limit is not equal to right hand limit, so therefore limit x tends to 0 of sine 1 by x does not exist. So hope you have understood this. Now let's move on to the next question. So here you see, for what value of small a the vector a, vector b are perpendicular, right? So vector a is given, so let me solve. Vector a is your small a I cap minus twice j cap plus k cap, and vector b is given that twice a I cap plus a j cap minus 4k cap, right? Okay, we know that dot product of two vectors, a vector dot b, that is equal to ab cos theta, right? Ab cos theta. So now to be perpendicular, if vector a perpendicular to vector b, right, so then theta must be equal to 90, and then cos 90 is equal to 0. Therefore this side, right hand side, will be 0. So a dot b will be equal to 0, and a dot b, so that means dot product of these two should be taken here, right? So what we're going to take, a I cap minus 2 j cap plus k cap dot twice a I cap plus a j cap plus minus 4 k cap is equal to 0. So hope you know how to find a dot product. So a I cap, 2a I cap, that's going to be 2a square, I cap their dot product is 1, then minus here you see minus 2j cap a is a kept, so minus 2a, right? Then this one and this one minus 4, right, is equal to 0, and dividing its term by 2, you will get a square a 2 is equal to 0. And if you split the middle term, what you gonna get? A square minus twice a plus a minus 2 is equal to 0. Just factorize this. a minus 2, then here 1 is taken common, a minus 2 is equal to 0. Therefore what you will get? A minus 2 a plus 1 is equal to 0. Therefore either a minus 2 is equal to 0 or a plus 1 is equal to 0. So this implies a is equal to 2 and this implies a is equal to minus 1. So these are the values of a for which these two vectors can be perpendicular. So these are the required values of a. Now let's move on to next question. So this is our next question. What is Wronskian and how is it used to find linear dependence of two functions? So this is the definition. If you take n real or complex valued functions, f1 from f1 to fn, f1, f2, f3, so on fn, and n number one times n minus 1 times differentiable. So that means if you had taken two functions, then that means 1 time differentiable. If you have taken 3 functions, then 2 times differentiable on any interval I, then the Wronskian is defined by this determinant. Okay, so in the first column you have taken f1, then first order derivative of f1, then second order derivative of f1, so up to n minus 1 order derivative of f1. Similarly, we're gonna do the same for f2, f3, and up to fn, right? So hope you have understood this. Now let me show you how to use this one to check the linear independence of two functions. So here you see, suppose we have taken two functions y1 and y2. They are linearly linearly dependent. So y must be multiple of some non-zero multiple of y1, y2 must be some non-zero multiple of y1. So then the Wronskian is given by this determinant. So here we have as we have taken here two functions, so we have to take here y1, then first order derivative of y1, that's enough. Then here y2, then first order derivative of y2. So here y2 is nothing but I have already mentioned here some non-zero multiple of y1, that is a y1 we have taken. Okay, so a is a non-zero number, right? A is not equal to 0. So now if you evaluate this, then you will get 0. So which shows that these two functions are linearly dependent function. So now let's move on to next exercise. Next question. So that vector b is perpendicular to a, where magnitude b is not equal to 0 and b is equal to time derivative of a. So now you see, we know that dot product of any two vectors is constant. It is a scalar, so it can be written as constant, right? And if you find a time derivative using the product rule of a dot a, then you will get a dot d a by dt, then plus dA by dt dot a vector is equal to 0, because derivative of constant is 0, right? So let me write this way, just wait, just let me rearrange this. Okay, so here you will get 0. So hope you have understood this. Now left hand side, we know that a dot b is equal to b dot a in case of dot product, right? So that's why you can write here what you can write. You can see we can write this one, a dot a by dA by dt plus a dot dA by dt is equal to 0. So 2 a dot dA by dt, right, is equal to 0. Now here you see that it is given b is equal to a dA by dt. So that's why you can replace this by vector b, right? So let me do on the other side. So here it implies a dot dA by dt is equal to 0 divided by 2, that's going to be 0, right? So a dot, so dA by dt is vector b is equal to 0. So since vector b is equal to dA by dt, that is given, right? So here you see, if dot product of these two vectors is 0, therefore b must be perpendicular to perpendicular to vector a. So hope you have understood this. And because you see, this dot product can be it will be 0 only in two cases: if either a and b is equal to 0, and or they must be perpendicular to each other. It is already given that magnitude of vector b is not equal to 0, and if we are getting a dot a is equal to constant, that means we are considering that a is also not equal to 0. Magnitude of a is also not equal to 0. So hope you have understood this. That's how you can solve this question. Now let's move on to next question. Now let's solve the next question. Evaluate using the property of Dirac delta function. So let me find the integration, evaluate this integral. So here minus infinity to plus infinity x delta x minus 4 dx. So here we're going to use this property that minus infinity to plus infinity f of x delta x minus x naught dx, that is always equal to f of x naught. So here is the x naught, whatever the value is there, maybe 1 to here if you compare with this one, here 4 is our x naught, right? So that's why its value will be so here f of x is simply x only, right? So this will be equal to 4 only, right? So just let me write here. So here f of x is equal to x, and x naught is 4. So since you can since this integration is equal to f of x naught, so therefore it must be equal to 4. So f of x naught is our here in this case we have only x naught, because f of x is x, so f of x naught will be x naught. So here x naught is 4, so it's gonna be 4. So 4 is the answer. So hope you have answered. The remaining questions will be solved in the next video, in part 2. This is part 1. So here we have solved from question number 1 to question number 2D, right? Sorry, 2E, right? Then we're gonna start from 3A in the next part up to the last question. Okay, last question. So that will be uploaded tomorrow. This is part 2. It's coming soon. So stay connected and hit the bell icon, and if you are new to my channel then don't forget to subscribe the channel and help me to grow my channel so that I can create new contents for you. And go to the poll in community post. So if you want me to create new course on physics, so I have given many options. Just choose one, which one will be voted highest voted, that will be selected to, and I'm gonna upload video lectures on that course from January 2023. So thank you for watching. See you in the next video.